So here is that HVAC control board broken down a little more, and you can see right here is all of the contact pads, where you basically have like a rubber pad over this with little squishy zones, and those squishy zones are what the plastic buttons actually press against. And when they press down, I don't believe they actually complete the circuit. I think what it does is the rubber is like a dielectric, and it acts like a capacitor, and that change in capacitance is what issues a logical signal. You can also see all of these little LEDs that are on the surface of the board here, and around this main knob, which I think that was like blower speed knob. What you have here was there was also a little acrylic spiral, and I threw it away. I don't know if I got it in here, so oh well. Anyway, it was a little acrylic spiral that takes light from these LEDs, and it makes that halo effect of light around the blower speed knob. And you can see the way that this knob works is it's actually a rotary encoder, and I can show you a better example over here. This is the driver's side temperature control, and what's interesting about this is that it has the rotary encoder, and you can see the teeth on the rotary encoder, and the teeth of the rotary encoder go in and out of a little tiny Hall effect sensor, and that creates the high-low, high-low, high-low signal that you get that serves as a digital input to the HVAC control module. Now, another thing that's really interesting about the driver and passenger side climate control is that inside of the knobs themselves, there is a very tiny little liquid crystal display, and that displays your 72 degrees for driver side and 65 degrees for passenger side, and and then there are also buttons, and these are those dielectric button pads that I was talking about right here. You can see this one as I'm peeling it up. You see that dielectric, see if I can zoom out here. Not sure if it's dielectric or if it's like partially conductive and it acts as a pull down resistor. I'll have to research these a little bit more, but they're completing the circuit on these pads right here, and I think that's going to be for your sync button. Now for the piece de la resistance, the big thing itself, the HVAC control module right here. It's smaller than my thumbnail. That little this is what's called a QFP package chip, so it's a quad flat package, and you can see that it has pins on all four sides, and it is surface mount. And these are pretty much impossible to solder with a soldering iron, but if you happen to have a hot air rework station, then you can make very easy work of it. I actually have this container right here contains recycled, and I have this QFP right here. That's a PIC32 microcontroller that came out of a Keurig coffee machine. So obviously it's smart enough to be able to control a very elaborate coffee machine with an LCD display and functions for different settings. The way that it's going nowadays, this black chip right here just looks like a solid black rectangle, but if you look on the bottom of it, you'll see that the pins for it are actually on the bottom of the chip itself, and this is what's called a QFN package. This is actually this tiny little black chip smaller than my index fingernail. That is 8 gigabytes of laptop RAM for a Google Chromebook. So we go to the back of this board here, and you can see K2XX dual zone auto HVAC, and that's your controls here. Now you have several other, I forget what the form factor code is for these pins right here, but they're basically like the surface mount equivalent of what the old style dip chips were. Dip chips being the ones in this case right here. They're a little larger. That's a dual inline package. And as far as other reusable components that I can take off of this HVAC board, got plenty of things. If we zoom in really close here, you can see all those little tiny black rectangles that are about that big compared to my thumb on the left hand side of the screen. Those are all transistors. And everything that's blue or black and is denoted by a R, like you see down here, R19, that's actually a resistor. That is, let's see, right there at the very tip of my thumb, that is a resistor. And all of these components can be saved and reused, and you never know when it just might be the exact component that you need to get your $700 gaming desktop motherboard working again correctly. We've also got some other things that typically go bad. Voltage regulators right here. There's also bridge rectifiers on here, and you might be asking, well, this is a 5-volt DC circuit. Why would I need a bridge rectifier if I'm powering it with 12 volts DC? Wouldn't I just need a voltage regulator? Well, the reason why a lot of automotive electronics have a bridge rectifier feeding them is because, with AC going into a bridge rectifier, I've got a couple larger bridge rectifiers over here. These are out of a motherboard and also out of a power supply for a desktop computer. AC current switches. And no matter what, it still provides positive on the positive out and negative on the negative in. So that means that even if I hook DC up to it, in fact, even if I hook DC up to it the wrong way, it will still power the board correctly. So what that is that's a form of reverse polarity protection. And if you've ever heard of some yahoo in an AutoZone parking lot hooking up a battery charger or a jump pack with the wrong polarity, and amazingly the car somehow survived, but all it did was it blew a fusible link, well, that's why. Our buddy in the wash bay, his girlfriend's Nissan 370Z, somebody did that, and she had the aftermarket package with the Bose audio amplifier. Well, apparently that did not have reverse polarity protection because something melted in it and started creating a power short to ground. And every time he would pop a new fuse into the fuse for that circuit, it would immediately pop again. So at this time, we suspect that's what it is. Some of my other stuff that I have around the house here, as you can see, I've been harvesting components for a while. I've got my test equipment over here, my oscilloscope, my power supply, soldering irons, hot air rework station, bunch of different various hand tools, new components, a computer, another computer, a couple more computers, and a whole litany of new components. Raspberry Pi single board computers, 02Ws. This is a whole computer. It's the size of a USB thumbstick. Also, we've got all kinds of microcontrollers. These are microcontrollers on development boards, so they make it easy for you because they've got pins and a USB cable to let you connect to them easily. And that's sort of in a nutshell what I do in my hobby room, and it's a work in progress, but there you go.